forever wala na. Oh,
Natapos tayo last
perfect
week ay
attendance
sa
pala kayo, no?
discount, right?
Sige. Today is 18th Feb. Hindi ko na
Kinig po
ika-count
ba ako?
sa inyo si Renz Aldrin. But since perfect attendance kayo, bigyan ko kayo lahat ng +1 sa quiz. +1 sa quiz for perfect
Okay, sige.
attendance.
Let's start na dun sa sunod natin na topic. Okay? So, hopefully ma-resolve
Teka lang,
yung conflict or magawa ng paraan kung ano pang pwede natin para magawa.
Class, give me 2 minutes. Lipat lang ako ng workspace.
Okay. So,
Hello?
Temperature po.
Okay. So, hindi tayo nakapag-intro sa first law, no? And forms of energy.
hindi po ba?
Sige. Dapat to. Okay. Share lang ako ng screen. So, today, ang target natin is matapos tayo sa forms of energy, tapos mass balance and energy balance, or yung first law of thermodynamics. So, visible na po yung screen.
Opo, ma'am.
Yes po.
Okay, so start tayo. So forms of energy. Energy is a measure of the capability of one substance or medium to dissipate power once this stored energy is utilized. So we have a lot of kumbaga different types of energy or forms of energy existing on Earth, even outside the Earth. So, but in thermodynamics, we will be focusing only to a few forms of energy, since these energy forms are the only energy involved in thermodynamics. So hindi lahat ay not all energy is gonna be discussed for this part of the course. So first is we have here the kinetic energy. Yes, Miss Lizelle, ikaw na lang. Miss Lizelle, please read kinetic energy.
Kinetic energy is well defined as the energy stored in a moving body. The higher the speed or velocity of one object, the higher is the measure of its kinetic energy. Assuming uniform properties throughout the system, the kinetic energy is given by Ke is equals to 1 half mv squared. Ke is equals to kinetic energy, m is equals to mass of the body, v is equals to velocity of the body. Note that v is the velocity of each lump of substance, assumed constant over the entire system. If the velocity is not constant for each lump, then the kinetic energy is found by integrating over the system.
Okay, thank you. So kinetic energy, guys, I assume you already discussed. You're already done with with dynamics, no? Tapos na kayo, no? Correct? Tapos na kayo sa dynamics? Are you done already with dynamics course?
Hindi po, ma'am.
Hmm. Oh! Wait, pero is it included in your POS or program of study for ME?
Opo, ma'am.
So when nyo siya iti-take pala? When siya,
Pag, pag po naipasa po namin ng SRB ulit ngayong semester.
ah, okay, sige. Alright. So kinetic energy, guys. This is the form of energy focusing on a body which is at motion. So if we later we'll discuss potential energy. So potential energy naman is just the parang counterpart ni kinetic energy wherein potential energy is the energy at rest. So yun yung focus nyo ngayon sa statics, di ba? The body is at rest. But in kinetic energy, the body should be in motion for it to contain or to have energy in it. Next is potential energy. So as discussed, this is the energy that a system possesses due to its elevation, h above some arbitrarily selected datum, is its potential energy and is determined from the equation potential energy is equal to mgh. So dito, class, potential energy, just a tip, if we discuss about thermodynamic systems, and of course, di ba, later di-discuss natin yung energy balance. If you did not, if you do not see any elevation or height sa problem, most likely the potential energy is negligible on that system. Okay? So PE equals mgh. P is the potential energy. M is the mass of the body. Acceleration due to gravity yung g, and then h is the height of the body. So, um, please take note pala whenever, example, mag-encounter kayo ng problems and then hindi present yung mass ng substance. Sometimes, problems are requiring us to solve for the specific ng energy. Meaning, pag nagkita kayo ng mga word na specific, meaning nun is yung sagot nyo is naka per mass. Example ay merong kilogram sa denominator ng unit, ganun. So, if specific kinetic energy, so your answer will be like kilojoule per kilogram. In potential energy naman, so your answer will be kilojoule per kilogram as well. So, per unit mass yung tinutukoy natin, or, or pag when we talk about specifics, no? That also applies to internal energy, to enthalpy, etc. So, when we say specific internal energy, that's denoted, di ba? Internal energy is denoted as U, capital U. However, when we talk about specific internal energy, so that will be denoted by the small letter U. Okay? But before we proceed dito sa next form of energy, let's have a sample problem. Visible na?
Yes po, ma'am.
Yes po.
Okay. So, sample problem number 10 na tayo. Correct? Natapos tayo sa temperature, which is sample problem number 9 yung at what temperature ay same yung Fahrenheit and Celsius. So this will be your sample problem number 10. So given dun sa discussion, given na yung mga formula kanina sa discussion, so I'll give you 2 minutes maybe to answer this problem. Raise lang ng hand ha yung makakatapos na. So the problem is an object is kept at height of 20 meters. It starts falling towards the ground. Find the velocity of the object just before it touches the ground. So nag-assume na lang ako na bola yung object and then mahuhulog daw siya sa ground. So what's the velocity of the object just before it touches the ground? May nakapagsagot na po? Anyone? Kahit try lang. Yes, Mr. Jeremy?
19.81 meters per second po.
Your answer is 19 point?
81 po.
Okay, that's correct. So, i-discuss lang natin. But in the exam ha, 8809 siya. 3 decimal places tayo. Anyway, sige, discuss natin. So, in this problem, we're given of the height of 20 meters. Ano pa yung given dito? Wala na, no? And of course, we have also the gravity, which is 9.81 meters per second squared. So in order for us to solve this problem, we have to take note or we have to bear in mind that at this position, at this elevation, we have here, or the object is possessing some energy here, which is of course potential energy, since the object at the top originally is at rest. So potential energy is stored at the body at this elevation. However, when the object starts to fall, example, nag-roll siya, and we have here negligible air resistance and friction, etc. Negligible mo na lahat. Meaning, ang force lang na mag-a-act sa object is the gravity, no? And assuming that this ball will fall vertically, like straight vertically, walang mga angle. So, before siya mag-fall sa ground, before the ball hits the ground, we are asked to find the velocity of the object. So, take note that at this point, at the moment before the ball touches the ground, that is where the velocity is the highest. Or that is where the kinetic energy is the highest. So, magka opposite sila ni potential energy. So, as the ball goes down, halimbawa nahuhulog na siya, so potential energy natin from a high value, bababa siya. However, when the object is already at motion, the kinetic energy naman yung mag-i-increase. Okay? So, we're asked to find the velocity of the object. So, we have the formula. In this case, potential energy is equal to kinetic energy. Bakit? Again, first law of thermodynamics, energy is not being created nor destroyed, no? It is just transforming from one form to another. So at this example, magsa-start siya containing potential energy, but that potential energy is just being converted to kinetic energy. So the moment that the ball is already at its lowest elevation but not touching the ground, so that's the assumption where the potential energy that the ball is containing here is almost equal to the kinetic energy that the ball has before it touches the ground. Are we clear on that?
Yes po, ma'am.
Okay. So, formula lang tayo, no? For potential energy, our formula is mgh. And then for kinetic energy, our formula is 1 half mv squared. So since we are not given of mass and this both of equations here contain the mass value, pwede naman siyang makancel na, no? So cancel na natin siya. Therefore, substitute lang tayo ng mga given. We have 9.81 meters per second squared times height natin is 20 meters equals 1 half v squared. So, we only have one unknown and we already have one equation. So, we will be able to solve for the value of velocity. So, 9.81 times 20, what's the answer? 100. Do you have your calculators with you?
196.2 po.
Sorry. 196.2 meters times meters m squared over s squared. So this is equal to 1 half v squared. So let's multiply both equations to 2 para makancel na tong uh, kasama ni v squared. So we have here 392.4 meters squared over second squared equals v squared. So at this point, the velocity is already, we can already compute for the velocity. So we just need to square both terms. Find the square root of both terms. So the square root of 392.4 is 19.809. Square root ng m squared is m. Square root of s squared is s. And other side of the equation, square root of v squared is v. So this is our final answer. The velocity of the ball just before it touches the ground is 19.809 meters per second. Clear po sa lahat?
Clear po, ma'am.
Alright. Then, balik na tayo sa ating discussion. Okay, Adham, please read potential energy of spring or elastic bodies.
Potential energy of spring or elastic bodies. In the same manner, the increase in potential of an elastic body can be measured proportionally in the amount of elastic deformation it possesses mathematically. This energy can be measured using the equation PES equal half kx squared. PE is equal to potential energy of a spring or elastic body. K, spring constant or stiffness of an elastic body. X, measure of deformation of a body.
Okay, thank you. So, potential energy of spring. So, ito yung spring class na we often see sa mga marami. Example, yung battery natin, di ba? Whenever we have a remote, for example, di ba, do sa paglalagyan mo ng battery, there's a spring there. No? So, basically, spring, yung parang curly na spring na madalas natin nakikita. So, concept-wise, the spring, before it is being compressed or before the spring stretches, the spring contains potential energy. And each spring that is available in the market has their own spring constant. So spring constant is the value, the numerical value that a spring contains, or the spring example, di ba, you have a spring, and then spring constant is the value of the stiffness of the string, where some springs can be easily compressed, or some springs have their own property wherein a certain amount of force or a certain amount of pressure is required before the spring moves. Ganyan. So spring constant is always given in a problem if we're looking for the potential energy of the spring. So hindi lang yan magiging given if that is the one being required by the problem. So let's have an example for potential energy of spring, sorry. Please try to solve. So this is your sample problem number 11. 2 minutes. Try to solve, then raise your hand if you already have the answer. Okay. May nakakuha pa na sagot? May nakapagsagot? This is just direct substitution class from the formula. Yes, Miss Hernandez, what's your answer?
8.1 times 10 raised to negative 3 joules po.
Correct. So that's correct. Anyone from the class who got the same answer? Okay, good. So let's discuss solution. So this problem, we're given of a spring. So, ganyan siya. So some springs have a force being applied on the top. So some springs naman are being stretched, no? Depending on the purpose why the spring was installed. So in this case, the spring is stretched up to 9 centimeters. So instead na pag ganito, pag ganon. Tiyan. Pag ganito siya yung nangyari sa kanya. So final um, form natin is mas sumaba yung spring. So yung displacement daw from this position up to this position is 9 centimeters. Yun yung i-stretch ng spring. And then we're also given, so ito na yung x natin. X is the displacement. So next, we're given also the constant or the spring constant, which is 2 newtons per meter. So formula for spring again is, what's the formula for spring? Potential energy of spring. Class? Gising pa ba? Gising na ba?
1/2 k times x squared po.
Correct. So tatandaan no, this is just, if you notice, this is just similar to the formula for kinetic energy. Pero magkaiba sila. Yung form lang, parang magkaparehas sila. No? So direct substitution lang tayo. Solving for the potential energy, we have 1/2 times the spring constant, which is 2 newtons per meter. And then we're given also the displacement, which is 9 cm. Pero in meters, what's the value in meters? 0 point,
09 po.
correct. So 0.09 meters squared. So potential energy that the spring contains is 8.1 times 10 raised to negative 3 Newton meter. And remember, Newton meter is equal to joule. So yeah, this is your final answer. Nakuha po. Walang tanong?
Ma'am, excuse me po.
Yes?
Pwede na pong direct na naka-decimal po na 0.0081 po.
It's okay.
Sige po. Thank you po.
Okay, sige. Proceed tayo on the next form of energy. Sige.
Hindi, malamig na.
Okay, next form of energy, we have internal energy. Mr. Reggie, please read.
Internal energy is an energy developed through the movement of the molecules within the substance, brought about a change in temperature. Any relative change in temperature of the substance will correspond to the change of its internal energy. It can be calculated using the formula U is equal to mc T2 minus T1, where U is equal to the generic symbol to define internal energy, M is equal to the mass of the substance, is equal to the specific heat capacity of the substance. It is also measure of thermodynamic capability of one substance to absorb and store heat energy. And lastly is T equal to temperature.
Okay. So internal energy class is an energy developed through the movement of the molecule. So when we talk about internal energy, we are focusing on a microscopic level, no? So we're talking about molecules here. And we are given of the formula for internal energy being the delta U. So this is change, no? This is the change in internal energy of a system. So since the internal energy is uh kumbaga, it is being affected by the change in temperature, so our delta U, or the change in internal energy, is equal to the mass times the specific heat capacity of a substance to be multiplied by the change in temperature in Kelvin. So we always use Kelvin when we solve for energy in thermodynamics. Laging i-convert to Kelvin or Rankine. So later ko na lang i-discuss yung sample problem. Let's proceed first with the flow work. Um, Dave, please read what's flow work. Okay, so let me just explain more of what flow work is. So, ano yung sabi sa problem? Flow rate is the delta PV, and meron din tayong sinabi na yung flow rate is the integral of the pressure times dV, or we have an instantaneous change in the volume. So for us to better understand this concept of flow rate, let me give you an example. So let's say we have a cylinder. Ay, ayoko pala ng ganito. 2D na lang. Let's have a cylinder. And then this cylinder has a piston. So we have molecules here inside the cylinder. And of course, when you have here molecules, so there is a pressure also inside here, the cylinder. So we have pressure acting on the piston itself, and we also have some, let's say we put some pebbles here at the top of the piston. Yan, example lang to. So let's say at this state or at this specific scenario, the piston is not moving anymore such that the pressure or the force that is present underneath the piston is equal to the force given by the pebbles. So these pebbles has mass, diba? And they also possess weight since there is gravity. So specific for this example, wala nang movement si piston. The piston is at equilibrium. This system is at equilibrium. So this in this portion of the cylinder, we have here the volume of the cylinder. Also, we have here the pressure, no, since this is being compressed by the piston. So, di ba, formula natin for work is also force times distance. And force, talking about pressure is force over area, di ba? So we can say that at this equation, we can get the value of the force by multiplying the area to the pressure. And substitute natin siya dito, we can say that the work is the area of the surface wherein yung force is being applied times the pressure times the distance. So now class, let's say nag-alis ako I removed two pebbles here. Let's say this is just the same. Kunwari, same lang sila. Pag nag-remove ako ng pebbles here, example, two pebbles, expectation is that this piston will go up, correct? Because the total mass acting on the top of the piston is being reduced. So, gagaan siya, the weight will be lighter, and then since this portion of the cylinder is pressurized, so this will push the piston to go up. So let's say yung piston natin is already here. And we only have now 4 pebbles. So mas gumaan na siya. And we have here the molecules and everything. But we still have the pressure acting on the piston. So class refresher. In this case, di ba, initially, yung volume natin is maliit lang, no? And the pressure here is high. But in this case, since nag-expand na yung cylinder natin due to the removal of some weights above the piston, the pressure here becomes lower compared to the first setup. So, ang sinasabing work class, itong workflow na tinutukoy natin, itong formula nito na integral of pressure times dV, sinasabi na yung work na ginawa or na nangyari dito sa system natin is yung pressure na nag-a-act dito sa surface natin multiplied by the change in volume. Di ba originally, nandito lang yung ating, nandito lang yung ating piston. Let's use different color. Diba no? Originally, nandito lang yung ating piston. And then, since gumaan yung pebbles at the top, nabawasan yung weight acting on the piston at the top side of the piston, nag-expand yung cylinder or yung part na ito, yung volume natin. And yung work na sinasabi dito class is yung naging change in volume. Itong part na to. 'Di ba originally ito yung height, yung level ng piston, and then nag-expand siya, nag-act si pressure, and then this this portion, this displacement is the work done by the system. So, kung ita-top view ko yan, eh di ba, this is a cylinder, di ba ganyan siya. And this is going back to the formula of work na na-derive natin. The work done by the system is equal to the area. This is the area of the piston times yung pressure na nag-a-act times yung distance na na-displace yung piston natin. Nagets po ng lahat? Kaya nangyari na yung formula natin for workflow or flow work is the change in pressure and volume, or the delta of pressure and volume from the initial state up to the state after the change. Na clear po sa lahat? So yung work na tinutukoy dito is yung displacement. Dun equivalent yung work done by the system. Clear ba?
Clear po, ma'am.
Okay. So yun siya si flow work. Next naman, punta tayo kay enthalpy. Please read, Billy. Billy?
Hello po, ma'am. Audible po
Hello.
ba?
Yep. Please read your enthalpy.
The total energy of the substance that it harness be capable of doing work. This is equal to the sum of internal energy of the body and flow work, which is H is equals to delta U plus delta PV.
Okay. So enthalpy naman, this is the total energy of the substance. So, di ba given na tayo ng, sige. Mas ma-appreciate natin to when we go directly na dun sa energy balance para mas ma-appreciate natin yung enthalpy. Move muna tayo sa entropy. Entropy, please read, John Jeremy.
Entropy has nothing to do with the measure of energy, as entropy depends on the state of the substance. Only entropy can be well defined as the measure of randomness of the molecules of a substance, the fraction of the total energy of the system that is not available for doing work. Due to energy stored in the body,
Nawala
hello po.
ata. Ayun.
Sorry po, nag-lag po ata.
Okay, it's okay. Sige. So, entropy has nothing to do with the measure of energy class. And entropy basically is yung parang disturbance doon sa system. No? So, this is the energy that is not available for doing work. So, kumbaga ito yung disturbance basically ano na lang, in madaling salita. So, punta na tayo sa sample problem ba tayo dito? Doon na lang sa energy balance para mas intindihan natin yung different forms of energy. So, punta muna tayo sa next topic, which is, ito class expectation ko na lang ha na you are all aware of this table. So this will be very important when it comes to solving problems, especially when you're doing unit analysis. No? So, basahin nyo na lang to and tandaan. Also, these conversions, so baka lumabas siya sa quiz, baka lang. And of course, since pupunta na tayo sa energy or we are going to start solving energy related problems, please take note also of the constants and conversions na meron kay energy. Examples, yung mga BTU to foot pound, etc. Calories, specific heat, you should know that. So I will not give that sa exam except yung ibibigay kong substance is not air or water. So again, if the substance is yung air or water, I will not give the constants. But if the substance in the problem is different, so I will give the specific heat values. Okay, so punta muna tayo sa law of sa first law of thermodynamics. But before we proceed with the first law of thermodynamics, I want everyone to understand first the different systems or the different types of systems in thermodynamics. So first, punta muna tayo sa aking note. This is thermodynamic systems. Thermodynamic systems class. Mamimili lang tayo niyan sa tatlo. So, we have three types of systems when we solve problems in thermodynamics. First one is we have the closed or open system. Next, we have the closed system. Then next is we have the isolated system. Anyone from the class who can differentiate open system sa closed system in terms of mass and energy. Let's focus on this two. What's the difference between an open system and a closed system in terms of mass and energy? May nag-advance reading ba? Yes, Mr. Aldrin?
Ma'am, sa open system po, mass and energy can cross boundary. Pero sa closed system po, mass can across but energy can.
Correct, very good. So in an open system class, mass and energy ay pwede siyang mag-cross sa boundaries ng isang open system. So, madalas na example dito being given sa mga problems is yung mga turbines natin, no? 'Di ba yung mga turbines is meron tayong input doon na mass and then nag-create siya ng work. So, the work is being done by the system and then meron din siyang output which also contains mass. So, in that example, in an open system, we have a mass going in, an energy going in. This energy could be a mechanical work, pwedeng heat, pwedeng different forms of energy. So, in an open system, meron din tayong lumalabas na mass. The mass can cross the boundaries as well as the energy. Next is for closed system naman. In this case, walang mass na nagko-cross ng boundaries. Yun lang, energy. Meron tayong energy in and energy out dito. Walang mass, no? Walang mass. And next naman, for an isolated system, so in this case naman class, we have a system that is completely isolated. And in this case, walang nagfo-flow na both energy and both mass and energy. So in an isolated system, walang nagfo-flow na mass and energy. So in this case, we can say that in an open system, sorry, in an open system, our mass na pumapasok dito is equal to the mass na lumalabas from the system. For a closed system naman, so the internal energy in a closed system can be calculated as the heat the relationship, no, of a mass of the mass in the system and the volume in the system. Sige, conservation of mass muna tayo. O dyan, Jeremy. Ulit.
Conservation of mass, which basically satisfied by the definition of a control mass.
Okay. So, conservation of mass. So, this is similar to the conservation of energy, no? This is conservation of mass states that the mass cannot be created nor destroyed. So, walang biglang susulpot na mass doon sa ating system. So, nagfo-flow lang siya papunta sa system, and this is the same mass that is going out of the system. Next, conservation of energy, Miss Shane. Valerie.
Conservation of energy. The first law of thermodynamics states energy cannot be created or destroyed. It can only change forms. Energy transformation is accomplished through energy transfer as work and or heat. Work and heat are the forms that energy can take in order to be transferred across the system boundary. The first law leads to the principle of conservation of energy, where we can stipulate the energy content of an isolated system is constant. Energy entering minus energy leaving equals change of energy within the system.
Sige,
The
okay na.
quantity of fluid.
Okay na. Okay na. Thank you. So, punta na tayo sa conservation of energy, or this is already the first law of thermodynamics. So, first law of thermodynamics states that energy cannot be created nor destroyed. It can only change forms. So, to better understand, mag-create tayo ng diagram mo. This is first law of thermodynamics. So let's say we have a system here. Di ba sinabi doon yung energy going into the system and minus energy leaving the system is equal to the change in the energy of the system. So in a thermodynamic system, we have energies going in, such as we have PE, the potential energy. We have kinetic energy, sub 1. We have flow work, sub 1. We also have sometimes the enthalpy going into the system. We also have internal energy, U sub 1, U sub 1. Of course, yung heat added to the system, meron din tayo. And when heat is added to the system, expect that there will be work na mapoproduce. Si PE2, meron din. Lalabas rin si KE1. Lalabas rin si flow work. Lalabas rin si enthalpy and internal energy. So, parang FBD lang, no? Ay, hindi pala. Bawal pala. I-form na lang natin yung equation. So, energy in minus energy out is equal to the change in the energy of the system. So, sabi nga ni first law of thermodynamics, hindi nakaka-create nor nade-destroy yung energy in our system. Nagta-transform lang siya from one form to another. So, it could be that the potential energy here is high, and then after the processes are being done in the system, the output potential energy is now low. So, saan napunta yung nawalang potential energy? Nag-transform lang siya sa different forms of energy. So, let's write the equation. We have here the heat, which is being added to the system, plus PE1 plus kinetic energy plus flow work plus the enthalpy plus the internal energy is equal to the work which was produced by the system plus the potential energy plus the kinetic energy plus the workflow to the enthalpy and the internal energy. So, di ba, yung mga change in potential energy natin is just equal to PE2 minus PE1. So, same goes for the other forms of energy. So, we can rewrite this as Q minus W. Transpose lang natin yung work from the right side of the equation to the left side of the equation. And then we'll have here a change in potential energy plus the change in kinetic energy. So, ito magta-transpose lang to the right side of the equation. Then, we'll also have change in the flow work, change in enthalpy, and change in the internal energy. So, basically, ito na si first law of thermodynamics. So, try tayo mag-solve mga para lang sa, ayun pala, before we proceed to the problem, sample problem, discuss ko na lang din here yung sign conventions natin if we talk about a thermodynamic system. Ito din yung madalas na pinagkakalituhan no, ng mga estudyante. So, in a thermodynamic system, and if we talk about internal energy, the delta U or the change in internal energy of a system is equal to the heat minus the work. Pero sometimes work is being done on the system, sometimes work is being done by the system. As well as for the heat, sometimes heat is being added, sometimes heat is being rejected. No? So para on the same page tayo when it comes to the sign convention, please remember that Q or heat is positive whenever the system absorbs heat. Or heat is added on the system. When heat is added on the system, ano yung process na yun? This is endothermic. Endothermic. Now naman, if heat is being rejected from the system, the sign of the heat is now negative. So this is heat being rejected or rejects heat. So this process is exothermic. Nagre-release si system ng heat. And then, pag sa work naman, negative ang work. Tanda na, negative ang work kapag the work is done on done on the system. And work is positive if the work is done by the system. So example ng work being done on the system. Let's say you have a tank, tapos meron ka ditong agitator, yung parang mixer, for example. So in this case, the work is being done on the system. Let's say you have water inside. The work is being done on the system. However, let's say naman you have a turbine, and turbine, pinapagana yan ng it's either kung ano mang energy. Example, pwedeng steam or pwedeng other media, no? Example, meron kang turbine. And turbine is a way or is an equipment which produces work. So if you have a turbine na nagpo-produce ng work, meaning yung work is being done by the system. Clear? Kung ano yung difference ng a work being done on the system and a work being done by the system. Clear tayo dun? Okay. So, sample problem tayo para ma-test yung mga sign convention. So, this is mm, sample problem number ano na tayo? 12?
12 po.
Okay. Teka, ikaka-copy-paste ko lang. So, isasend ko to. Meron akong compilation ng mga sample problems. Isasend ko na lang after natin i-discuss. Mhm. Okay, calculate the internal energy. So, gaya na sinabi ko kanina, no? Anong formula ng change in internal energy? That is just change in internal energy of the system is equal to the heat minus the weight. However, we must be mindful of the sign conventions. So, this is A, B, C. Sabay-sabay natin isolve para di na tayo malito in the future on the sign convention. Okay? So, ako na lang magsasolve. So, for the first one, naka-share naman ako ng screen, no? Tama. Yes.
Opo, ma'am.
Okay. For the first one, solution tayo. First one. The system absorbs 300 joules of heat and performs 500 joules of work. Calculate the internal energy. The system absorbs heat and performs work. So dito, work is positive or negative. Yung system nag-perform daw ng work. Work is hello?
Positive po.
Correct. Work is positive. So this is 500 joules. And then the heat is absorbed by the system. May inabsorb si system. Ito yung system natin. May inabsorb si system na work, na heat. So your Q is positive, negative. Correct. Positive. So this is positive 300 joules. So pag pinakompute tayo ng change in or ng internal energy, this will be Q minus W, no? So, direct sub lang. 300 minus, minus yan, positive 500 joules. So, the change in internal energy is negative 200 joules. This is for the first one. Sige, solve din natin yung second one. Letter B. May system tayo ulit. And yung system daw natin is nag-absorb ulit ng heat. And the surroundings perform 300 joules. Meaning, anong ibig sabihin nito? Yung surroundings daw nag-perform ng 300 joules on the system. Yung work natin ay ano?
Negatives po.
Sorry, ano yun?
Negatives po.
Correct. So, ito, surroundings, di ba ang system, meron tayo system and surroundings. So, si surroundings daw ang nag-perform ng work doon sa system. So, in this case, our Q is still positive. We have positive 720 joules. And then, the work is performed on the system. So, meaning, negative ang ating work. So, we have 300 joules. Therefore, the change in internal energy in our system, Q minus W, substitute 720 joules minus negative 300 joules. So the internal energy in the system is 1020 joules. Naintindihan po ng lahat? Nalilito pa?
Gets po.
Okay. Next, letter C tayo. Letter C, we also have a system. And then 400 joules of work is done on the system. And the system loses 225 joules of energy. Meaning, nawalan siya ng 225 joules of energy. 225 joules. This is Q. And if the system loses energy, the Q is negative. Teka, burahin ko. Kamali to. So, yung work was done on the system and the system loses energy to the surroundings. Therefore, yung ating internal energy dito, Q minus W. So, W natin dito is 400. So, negative 400 since it was done on the system. Q natin is negative din kasi that was the energy lost dun sa system natin. So, Q minus W, we have negative 225 joules minus W, negative 400 joules. This is equal to 175 joules. So, ito siya. Ayan. Yun si internal energy, and that's how we assess yung exchange ng heat and work doon sa system. So next, meron akong sample problem na ibibigay sa inyo. So isolve nyo na lang ito, no? Try nyo munang isolve on your own before nyo i-search yung sagot sa internet na. Try nyo muna mag-practice. So, stop share ako. Sample problem, ano yung huli natin?
12 po.
12. Okay, so please solve itong dalawang sample problems. Sa notebook nyo rin, itong sample problem 13 and 14. And then, we'll discuss the solution on our next meeting. And ibibigay ko na rin sa inyo yung copy nito. Nitong file na to. No? So, nandito lahat ng sinolve natin from the start up to this topic. Okay, your assignment is solve sample problems number 13 and 14. So far, may katanungan po from the class? Yes, Mr. Miguel?
Ma'am, pwede po pa-zoom ng konti kasi hindi po masyadong mabasa.
Sorry. Ay, ito, ibibigay ko naman yung copy sa inyo. Itong word mismo. Ilalagay ko dun sa ating classroom.
Okay po, ma'am. Thank you po.
Sige. Ito, hindi pa natin nadidiscuss yung sa mass balance. Pero i-advance study nyo na rin para next discussion ay mabilis na tayo. So yun lang class, may tanong pa po. I-upload ko na to. 205. Upload. May tanong pa class? I-upload ko na lang ngayon. As in after ko i-drop yung call. Wala pong tanong?
Wala na po.
Okay, if that's the case, dismiss na tayo. Thank you everyone. Breakfast na din.
Thank you po.
Thank you po.
Thank you po.
Thank you po, ma'am.
Thank you po.